Hi folks, this is Nikhil and you are learning GoLang with me. Till now, I have covered the basic fundamental concepts of GoLang, and I also covered the advanced concepts such as working with JSON and then um, advanced looping, recursion, function as the first class citizen. So you have closure, um, you have the ability to pass the function, you have the ability to use the anonymous function, and so on. Now, starting with this particular session, I'm going to talk about the concurrency. And concurrency is one of the most important aspect of any programming language in today's world. Without concurrency and parallelism, you cannot imagine writing a program. Wait a minute, what did I just say? Well, I just said that concurrency and parallelism are two different concepts. These are not two similar concepts. So if you are already aware of the concurrency and parallelism and then the difference between them, then that is well and good. However, for those who are not aware of these two concepts, here are my 2 cents. So concurrency is part of the parallelism. So concurrency is a subset of the parallelism. What is parallelism? So by the definition, parallelism means you can execute the programs in let's say multiple programs at the same time. So let's say you have 4 programs, and let's say 4 programs have 10 instructions. Then by parallelism you imply that all those 4 programs, so let's say there are 40 instructions overall, so at least at a same time in all of the program one instruction is getting executed, right? That's the meaning of parallelism. So parallelism require you to have many resources, many processors. If you have single processor computer or machine, then you cannot have the parallelism in your system. You may have the concurrency, and that's why the concurrency concept originated. So before 2006, there were no dual core or quadra core. Now you can have many core processor nowadays, but at that time there were no dual core processors. So that's why the concurrency concept was originated, and many languages that include Scala, Java, all of these JVM based languages especially, they actually leverage the concurrency concept. Yes, that it is there in C, it is there in Python and C++. However, in my opinion, Java is the language that actually took this concept very seriously and provided different different constructs to and those are the higher level constructs, not the lower level constructs like we do have in C, to actually leverage the concurrency. So actually it made the life of the developers very easy, so that developers can just use the higher level constructs and then can you exploit the concurrency of the machine or of the system. Now, in concurrency, either you have the parallelism inbuilt. So basically, yes, if you have multiple programs running in parallel, then that is concurrency plus parallelism. However, in concurrency, the important concept to understand is you have a thread, and then that particular thread is responsible to execute the instruction of your program. Now, whenever there is a let's say multiple programs or multiple applications run, then to imitate the parallelism, what happens is let's say that particular thread starts with executing the most priority application. Then it executes few of the instructions, and then let's say it reaches a point at which there is a wait operation involved. Maybe there is a call to the external REST request. Maybe there is a call to the IO, which is part of the same machine. So let's say you want to do some kind of hard disk operation, you are transferring the data to the disk, then obviously there is some kind of IO involved, and then because of the IO you are blocked. Now at that time what would happen is your main thread will switch to the other application and execute few of the instructions from that application. Now, so that is the concurrency in a nutshell. So basically concurrency imitate the behavior of the parallelism so that the user gets the impression that multiple applications run in parallel. So even if I just toggle in between, and then if I have many threads, but then finally even though my processors are occupied, all of the threads are occupied, then finally some application will have to wait. So that's why you do see the bees spinning. You do see when the processor is running, let's say 95%, 98%, 99%, then you start to see the slowness in your system. That's the reason that you don't have the resources to execute the multiple applications. So that's why you cannot just spin off a new application and then keep on consuming your processors. There is a limit. Only the limit is whether you have the single core, or you have the dual core, or you have the quadra core processor. And with this concept now getting cleared, let's understand the basics of the concurrency. So now in order to have the concurrency or the parallelism, now you know that the hardware is extremely important. Now let's see in GoLang, when we will see the higher level constructs, like a join, like a cyclic barrier, like a countdown latch. I'm talking about the Java constructs and then mapping those to GoLang. And if you are not aware of these constructs, don't worry, I will explain them in a different session in a detail. So if you are not aware of these jargons, just skip the video and see the last part, in which I am now going to explain how to get the data, the metadata of your hardware. So in GoLang, you just have to use the runtime package. So let's say if I want to understand what is my architecture, whether it is the x86 or whether it is AMD, let's figure it out. So let's say architecture of machine is, let's say, so you just have to use a runtime GoArch. That's it. Then let's say this is display the architecture details. Then this is to understand what kind of OS you have, whether you have Linux distribution, whether you have Windows, whether you have Mac. If it is Linux distribution, then what kind of Linux distribution. So display the OS details. And believe me guys, this is the package that GoLang uses behind the scene in order to perform all of the higher level constructs that we are going to see, and all of these are the APIs. Then the next part is, if I want to understand how many processor do I have, whether it is a single processor, whether it is dual, or whether it is 4, or whether it is more than that. So over here I just want to display the number of processors, because that actually decides how many tasks I can run in parallel, isn't it? So number of processors. So over here you need to use Go. So Go runtime Go and num runtime num CPU. And lastly, now with that, I will close the session. But lastly, I just want to focus on the yeah. I just want to focus on the number of threads with which you can actually distribute the task. Let's see how to do so. So that is known, the threading in GoLang is known as a routine. So display the number of routines, and the API is num of coroutine. Now let's run the program, and now you will see that this is AMD 64, OS detail is Linux. I have the 8 processors, so that implies that at least I will be able to run 8 tasks in parallel. Number of routines, and currently there is only one routine. Why there is only one routine? Because I only have the men. So what is happening is when I click on the run go, when you have this runtime configuration, which is over here, when I execute this program, automatically what happens is the main gets executed and only one thread is allocated to this program, and I currently my resources have this many threads and my processors are idle. So that's why one of the processor takes this program, executes it by allocating a thread to it, and then because there is only one thread, which is the main thread, then that's why the number of routine right now is 1 that is allocated to this program. Now in the next session I will explain in detail how you can just spin off a new task and assign a different thread to it. Let's see how to do so in the next session. In this session we have just seen what is the difference between the concurrency and the parallelism, and then we have also seen how to get the basic details of the architecture or the processes that your machine or your server farm has. And if you go to the runtime package, then you will see all of the different APIs, packages are there. So if you are interested, then you can go to the spec runtime, and then over here you can go to the package runtime, and then you can explore a lot in this package. So runtime GoLang, import runtime, and then package runtime contains operations that interact with Go's runtime system, such as functions to control Go routines. It also includes low level type information used by the reflect packages. So if you want to explore a bit on this, you can visit this page, and then over here you can understand what is the num CPU, num cgo call, num go routines, number of go routines, and all this stuff, the fancy stuff, I will say. That's it for now. See you in the next session.